The objective of this lesson is to solve multiplication problems using partial products. There are many ways to solve a multiplication problem. When two numbers are multiplied together, the resulting answer is called a product. For example, 4 times 5 equals 20. The numbers 4 and 5 are factors and 20 is the product. We use the term partial product when part of the product is considered. We could rewrite the expression 4 times 5 using the distributive property. First, we begin by decomposing the 4. So now we have 2 plus 2 times 5. Then we're going to distribute the 5. So we have 5 times 2 plus 5 times 2. These equal 10 plus 10, and these are partial products of our original simple expression, and our product is 20. One way students can set up a partial product model is to draw a rectangular array. We'll use the problem 4 times 735. After drawing the array, the factor 4 will be recorded on the left, and the other factor of 735 will be recorded across the top in its expanded form. So 735 is equal to 700 plus 30 plus 5. We will multiply the factors of 4 and the second factor in expanded form and record the products in each box of the array. 4 times 700 equals 2,800. 4 times 30 equals 120. And 4 times 5 equals 20. Each of the products in the array are considered partial products of the original problem, 4 times 735. Now let's add each partial product to find the sum. 2,800 plus 120 plus 20 equals 2,940. Let's look at a different model of the same problem. We'll record this next to the array to better see the connections between the two models. We begin with multiplying the factors of 4 and 5, although it doesn't make a difference which order we use. Next, we'll multiply 4 and 30. Remember that 3 represents 30 because it is in the tens place. And finally, multiplying 4 and 700. Now we'll find the sum of all our partial products. We can easily see the connection between the array model and the vertical model. Both are a version of the partial products algorithm. Let's see how this works with two two-digit numbers. We'll use the problem 23 times 58. Draw a 4 by 4 array, and on the left write 23 in expanded form, 20 plus 3. And across the top write 58 in expanded form, 50 plus 8. Find the partial products of each square in our array by multiplying the factors. Remember, there is no particular order. I'll begin with multiplying 20 times 50, which equals 1,000. Then 20 times 8, which equals 160. 3 times 50, which equals 150. And 3 times 8, which equals 24. The sum of the 4 partial products is 1,334. Just for fun, we'll record this same problem vertically so we can see the connections between the two models. 20 times 50 is 1,000. 20 times 8 is 160. 3 times 50 is 150. And 3 times 8 is 24. The connections can be seen between the array model and the partial products when they are next to each other. The objective of this lesson was to solve multiplication problems using partial products. We met this objective by practicing two multiplication models using partial products. Many of us are familiar with the traditional way of multiplication. While these models take less notational room, it also requires memorization of very specific steps in a certain order that, if done incorrectly, will cause incorrect answers. Using partial products, students can use their knowledge of place value and number sense in random order to find the products to multiplication problems. Your student should be able to successfully find the product for a multiplication problem using a partial product model of their choice.